turn off my camera now. The mic will be open. And if you have any questions, feel free to either put them on the chat or...
Thank you, Pratyush ji.
Yes.
Thank you, Pratyush ji.
Sure.
So, audience, we are now having one of the dynamic personality from MathWorks. So, he will be handled all the operations related to MathWorks and MATLAB simulation, especially 5G aspects for this course. First of all, Pratyush ji, thank you very much for accepting our invitation. And I know the session is going to be interactive and enjoyable. Once again, we thank you a lot for accepting our invitation.
Sure. Great. Thanks a lot, sir.
Please, one more request. Can we record this session with your permission?
We can. Yeah.
Thank you.
That's possible. Yeah. Right. Thanks a lot, sir. Right. So what I'll do now is probably again maybe turn off my camera and go ahead with sharing my screen. Right. Let me do that. Right. I think I'm sharing my screen. Can anyone please confirm if the screen
is visible? It is visible.
Okay, thanks for confirming. Right. So today we are planning to discuss a bit on integrating AI in wireless communications, especially 5G. So we will kind of go through examples. We will see how you can run different. I mean, if you have 5G data and how you can actually generate 5G in our waveforms, and then maybe pass it through some kind of machine learning algorithm to get predictions or do some kind of regression out of it, right? So in case you already have a system at your end, I would recommend that you at least download the files, right? So all the files that we are going to kind of go through for today are captured in this link, or you can scan this particular QR so that you can download the files. Okay. What I'll do is I'll probably share the link on the chat so that it's slightly easier for you. Right. So let me just go ahead and do that. It's a tiny URL link. What it will do is it will So I will probably pin this message so that everyone can kind of click here and navigate to this particular link. Okay. So what? Let me just click on this link and show you what you will get to see. If I just bring up the link that we have. So whenever you click on that tiny URL link, again, that is kind of pasted on the chat, you will reach here, the MATLAB drive page. Okay. And in the MATLAB drive, you will see a particular, actually, I'll just stop presenting and again show you how to kind of access that. Yeah. So whenever you click on the link, right, which has been shared in the chat, we'll come across this particular MATLAB drive page. You have an option to download the folder, or you can just add it to your MATLAB online. But the name of the folder will be nitj_ai_wireless. So this is how you can kind of get access to all the files that we will be trying out today. I will take some time so that everybody can at least download these content on your end. If you are facing any issues while doing that, please let me know in the chat or unmute yourself. think that will be helpful. So the link that we are using for downloading these files has been pasted on the chat. So feel free to click on that link and it will redirect you to this particular page. Now, how many of you are able to click on this link and navigate to this page? If you are able to do that, can you please type yes in the chat so that it's easier for me to understand? There's someone who has raised hand. Yeah, please go ahead. If you are raising your hand, you can unmute and speak maybe. Yeah, I think quite a few people have typed yes. Great. Thanks for confirming, everyone. You can also download the shared folder and open it on your own MATLAB. How many of us are able to download the shared folder? Again, yes or no in the chat. Yeah, I think quite a few yeses. Again, thanks for confirming. Awesome. Anybody facing any issues while either accessing the link or downloading the files? Feel free to let us know in the chat. I think we can wait for a couple of minutes before going ahead with the presentation, just to make sure that all the participants have access to these files. If you are facing any issues, just let us know. So just to repeat, we can click on the tinyurl link, tinyurl.com/ai-wireless-files. If you click on that, you'll come across this page, and here you can download the folder. Mr. Santosh mentioned that file has been downloaded. Someone mentioned, all right, great. Thanks for confirming. I believe most of you were able to do it without much hassle. What I'll do is I'll probably shift to the presentation now. So I'll stop for a while and again shift to the presentation. Okay, so let me share again. Right, so I hope we are able to download the files and we have it open up in our end so that we can follow along as I'll be showing a few demonstrations soon. So as far as agenda for today is concerned, these are some of the topics which we are planning to cover, right? So how do you kind of create wireless signals? How do you model neural networks or other algorithms in MATLAB? And once you are done with it, how do you kind of integrate that with different hardwares, right? And towards the end, I will also maybe discuss a bit in general how we kind of support initiatives for academia and summarize it. And if there are questions, feel free to let me know. So any place you feel any doubt, just put them on the chat or unmute yourself. I'll be happy to answer them. Right. So I guess, most of us are interested about 5G today. So I think option A would be the most predominantly chosen one. So I'm skipping this. But just to take all of us through the journey that we have taken from 1G to 6G. So it's basically generations of how you can transmit information through really advanced communication systems. So when it started, initially it was just analog communication, might be sent through a single cable. So it was 1G. Slowly we moved to 2G, where digital communication and text messaging, all of that was accessible. In 3G, CDMA kind of technologies came up, which was mostly mobile broadband. Slowly we moved to LTE, where cloud was involved and mobile broadband became more advanced, where multimedia data handling was possible. And finally, in 5G, we came through, it was able to address a lot of issues. For example, enhanced mobile broadband, if we needed very high data rates, if we wanted to connect with large number of devices, so massive machine type communications. If we wanted to operate in very low latency environments, that was also possible. Now, we have also started exploring 6G, and towards the end of it, I'll show some resources around how you can explore 6G type systems using MATLAB. But this has been the overall way how communication systems have evolved through multiple generations, right? Now, previously, before AI became really popular, we typically used to use standard algorithms for different applications in communication systems. But we nowadays demand a lot of services from the system, and traditional approaches might not be enough to kind of meet them. And through a lot of research, we have kind of seen that AI shows a lot of promise in meeting these expectations. And as system complexity kind of increases, which has been happening now, maybe traditional algorithms might not be able to satisfy all those complex systems. So where can AI really contribute? It can help you to kind of simplify networks, really improve performance, make you use the bands, the frequencies really efficiently. And there are other applications also. Now, initially, as you can see, AI was pretty much nowhere. But the question is, the mathematical models or the deterministic rules or the algorithms that we initially designed for different communication we typically started using AI. Now, whenever it comes to communication systems, we can take a multi-level approach to it. So let's say there is a node here and there is the user equipment here. We can think of AI in multiple modalities, right? We can first think of, say, link level AI. So all these devices are kind of linked to each other and if you take device identification, if you're trying to design pre-distortion filters, if you're trying to design beamforming, which is an integral part of 5G, all of these applications can so beam management. All of that is possible through AI. And use AI with wireless. Okay, so AI is just a part of the entire wireless workflow. You can use AI for other applications also, but it's just a part of a larger engineered system, which is the wireless system. AI is just a part of it. So engineers who are domain experts in wireless, we are trying to make sure that they don't have to struggle a lot with designing AI systems, and they can use their domain knowledge and just integrate some kind of additional in terms to all toolboxes. These are faster versions and very efficient in terms of operation. So feel free to download the latest version of MATLAB in case you want to get the latest functionalities in terms of 5G or wireless workflows. So just to walk you through the basics in case you are very new to MATLAB. That we are on the same page. If you are trying out things, say defining variables in MATLAB, if you type out something like a equal to 4, so this thing gets saved here and in the workspace also. Okay. So any variable that you save kind of gets saved in the workspace, and in the subsequent demos also we'll get to see that. Okay. Just to understand, are the font sizes readable enough? Can anybody confirm in the chat, or should I kind of enlarge them so that it's easily visible? These are visible. Okay. So in case I want to increase the font size, let me actually go ahead and do that. Let me actually increase this to 24, maybe. Yeah, slightly larger. Yeah, it would be good. Thanks for mentioning that. I make it 26. Is it better now? Increase the font. Okay, let me actually increase this also. Better? Should I enlarge further, or is it okay? If you look at these and these, I think I can see a thumbs up. Yeah, thanks for confirming. But others, are they visible? Are they okay? Great, awesome. Okay, let me just for safety make it 20 maybe, and make this 28. Yes. Okay. A little bit larger. Okay, for 30 to round things off. Better now, everyone? Font wise and everything visible? Font size increase. Okay. Let me do that. Yeah, I guess this will be okay for now. Yeah. Right. I guess this is visible now. I think a few people have confirmed also. So, great. So, like I was saying, you can define variables and they can get saved. If you want to define things like, arrays. So MATLAB essentially means it's a short for matrix laboratory. So if you want to define matrices, you can do that also. So if I am typing something like, say, ARR, which is 1, 2, 3, 4, 5, 6. So this is how I kind of define matrices, right? If we want to multiply a scalar with these matrices, I can define a new array and do 2 into the previous array. So all these numbers will get multiplied by 2, right? Now, an interesting thing about matrices, or at least MATLAB, is it assumes that any kind of operation that you are doing is a matrix operation, right? It was designed with the purpose of handling matrices in a better way. So most of the operations that you will do in MATLAB, if you take if you take multiplications, it will assume that it's a matrix multiplication. Okay. So you have to be careful there, just to ensure that there are no size mismatches and all of that. So for today, the folder that we are going to use will be this one, nitj_ai_wireless. If you want all the files to be downloaded at your end, or at least you want all of them to be accessible, just right click on that. There will be this option called add to path. Okay. And there, if you click on it, there will be two options. Just select the bottom one. Okay. Selected folders and subfolders. So once you have downloaded the files and you are able to access it, just right click on it, go to add to path, and there will be two options, selected folders and subfolders. Okay. So if you click on selected folders and subfolders, all the files that you have access to will be accessible. You can access all the files within this folder without any warnings. Okay. So just add them to the MATLAB path, so MATLAB can access all the files and folders and subfolders very easily. Okay. So this is how at least you get access to the files and folders and subfolders. Okay. So for today's demo, we'll be going through multiple folders. But before that, let me show you something. How many of you in the chat are aware of something known as a live script? If you are aware of it, type yes. If you are not aware of it, type no. It's for me to understand. Yeah, I think Someone mentioned no. I think most of you, I can see mostly no's. Anybody who have tried out? Okay, I guess most of you are new to LiveScript, so that will be interesting. Okay, great. So I'll first maybe take you through what a LiveScript is, because most of the demonstrations that we will look at today will be done through LiveScripts. So just to give you some context. So at the top, I guess most of you are aware of scripts. Okay, so if you click on a new script, this is how a script works. So you can define things. So let's say a equal to 5, b equal to 6, c equal to a plus b. And if you just run this, it will kind of ask you to save. Okay. And it will print out the output, right? So it's easy. You just write the code. You are aware of how, you write some algorithm and it will print something out. Okay. So this is the typical workflow that we take. And the extension is a .m extension. Okay. So this is typically how people write scripts in MATLAB. The problem here is if you want to make the script really interactive, you might have to use things like comments, right? So let's say comment something on the top saying that adding two numbers. Okay. And it explains what it does. But if I want to use more things here, let's say images or even headings and stuff like that, it will be difficult for me to do. Which is why instead of using a normal script to make it more readable and to make it more interactive, we use something known as a live script. Okay. So how do we access a live script? So under Home tab, you can click on New Live Script, and this option will come up. So if you notice the difference, this one was a .m file, a regular script. A live script has the extension of .mlx. Okay. So what's so unique? So if you go to the Live Editor tab, which is available with these live scripts, you can toggle between text and code, right? So if I click on text, and I can give a title to this entire thing. So I can say, 5G workflows in MATLAB, something like that. And below that, so this is the overall heading. Below that, you can kind of explain what you're trying to do. So you can say, in this script, we will explore how to design 5G NR systems in MATLAB. Something like that, right? So below that, you can create some code and you can say that, maybe design a 5G, some waveform. So for that waveform, if you need some time information and you want to generate the sign of it, you can also generate the plot of it. So if you run this, not t, but maybe something else, maybe plot t comma y. Okay, or maybe make it 2 into pi. Right, you can generate a sine wave. Okay, and so this will be one section, and you can have another section which will have a different explanation. So you can say that, okay, in this section we will explore LDPC coding or something. And then you can add another code. And so the idea here is you can segment the entire script into small sections, which are kind of independent to each other, and execute them independently. So that saves time, makes your code more readable, And yeah, it can also be exported as a PDF. Okay. And in fact, you can also insert things like equations. So if you have an equation and you know how to work with LaTeX, you can put it in the LaTeX format and add that. You can use images and all of that. So that's how a live script works. It's an interactive kind of script where you can add a lot of things to make your code more readable, okay, and document things in a better way. So now, given that we have some context into what live scripts look like and how they operate, and how is it different from a typical script that we use, we will go to the first thing. Okay, so we will go to the first getting started folder. Just click on solution_getting started. So this is about getting started with different networks. Actually, let me clear all output. So just like I mentioned, this is a live script. It has a heading. It has, the explanation on what we're trying to do. So for the first part, what we will do is we will ensure that whether we are in the correct directory or not. So we have written some script just to ensure that we are in the correct directory. So if I run this particular cell, only from line 1 to line 12 will be executed. Okay, only this part will be executed. And the goal of this part is to ensure that we are in the right directory so that all the files are accessible properly. So if we run this, it's telling me to navigate to the proper directory. Okay, so fine. So I will go to helper files and then try to run this. Yeah. So it's again telling me to kind of navigate to the proper directory. Let me go here, maybe run this. So the section is right. So I am in the first folder, which is getting started. And here I have the helper files. So it's telling me that, okay, you are in the right directory and you can continue with your work. So the next part is to have some kind of pre-trained CNN. So before proceeding with the pre-trained CNN, how many of us are aware of CNNs? If you have used CNNs or have heard of it, can you type yes? So CNNs essentially mean convolutional neural networks. How many of us have heard of it or used it? I think Shubham mentioned yes. Koteshwari mentioned yes. Others? Are we aware? Okay. I can see quite a few yeses. Okay. So most of you, I believe, are aware of CNNs, convolutional neural networks. So this is a type of deep learning algorithm, and we have already trained this network on some kind of data. And we have stored that data as a .mat file, okay? So the network is kind of available in this .mat file, which is this one, which is available in this network. So what we will do now is we will kind of load it. So if I load it, it will take some time to kind of load. And once you load it, here you will see one net variable has been loaded to the workspace. Okay. And other things like frames and labels also, but there is this net, which essentially is the neural network that we are using. So some, I think Rashmi mentioned have heard but not used. So I will give you some context. I mean, we will build that network. So I think during that time things will get more clear. Okay. So for now we don't know what it is, but it is some kind of network which can be used for different communications applications. So if I have this network, a neural network typically contains multiple layers. Okay, neural networks are deep learning networks, and it's called deep learning because there are multiple layers which are stacked together. So if you have a large number of layers, it's called a deep neural network. Okay. So if I want to kind of investigate what constitutes this particular network, I can look at the layers of it, or at least their names. So if I run this, this is the overall layers that we have. Okay. So what do we have? It starts with an input layer. Then we have a conv1d layer, then a ReLU, then conv1d, then a ReLU, and so on. Finally, you have some kind of output layer, because the problem that we are solving by using this network is a classification problem. Okay. What kind of classification problem? That we can kind of understand by looking at the classes. Okay. So these kind of networks are mostly used, they are used for image classification or different types of classification. So let's say I have a network which I'm using for classifying images of animals. Okay. So it can be the image of a cat, it can be the image of a dog, it can be birds or insects also. So the class names are essentially the categories of those living beings. So it can be a cat, it can be a dog, it can be an insect, it can be birds and stuff like that. By looking at those images of these organisms, it can kind of understand different patterns in those images, and based on those patterns, it can predict things in future. Okay. So for example, here, if you look at the classes, these are different modulation schemes, right? So 16QM, 64QM, PPSK, GFSK, and all of that. So if I have different modulation schemes, I can generate signals based on those modulation schemes, right? Now, if that is the case, and if I have those signals, and if I feed them to these kind of networks, how can that network predict the type of modulation scheme? Okay. So this is the application that we are looking at. We are looking at a modulation classification problem. So if I have signals coming from different types of modulation, and I feed it to a neural network, will it be able to predict the kind of modulation by looking at those signals? Okay. And it can be one of these 6 kind of modulation schemes. Okay. Now, let's say I select one of these modulation schemes and I try to kind of classify that. So let's say I have chosen 64QM type of modulation scheme. Once that is available, I am trying to select a particular data frame of that modulation scheme and try to plot its histogram. And then maybe I can feed that histogram, I can feed that, not histogram, rather spectrogram, to a particular network and get the right prediction. So this is a 64QM signal, and this is its corresponding spectrogram. What if I feed this image data to a particular neural network? Will it be able to classify that properly? Yes, because if you look at the prediction is 64QM, and the original data is also 64QM. So my network is able to predict the modulation scheme properly in this case. Okay. But will it be able to do that always? Is the question. In the next example that I'll cover shortly, we will see how to do that. Okay. One thing which you might have noticed here is this kind of drop down. Okay. Typically in scripts, you might not be able to come across these kind of drop downs because they are mostly just some kind of variable or some kind of value. In this case, you can use drop downs and you can use other things also. So it can be, a drop down, it can be some kind of slider. So if you introduce a slider here, you can swipe the slider horizontally and it can change values. Okay. So these are some interesting UIs you can play with in live scripts so that you can navigate between multiple types of data. But I'll stop here before moving on to the next demo. At least is the motivation behind why we are using deep learning in this regard clear? Or is this example in general clear? You can type yes or no in the chat. What we are trying to do. If you have questions, feel free to kind of put them on the chat. I'll be happy to answer. Okay. I'm having a challenge after loading the pre-trained CNN. Can you further elaborate? What kind of error is? Okay, got an error. Yeah, what kind of error again?
Yeah, I got an error. So I want to copy it. It says dot indexing is not supported for variable of this type.
Okay, so this one, right? Net.layers, this part you are not able to run? Is that the error?
Yes.
Okay.
After it loaded line 13, which is loaded the pre-trained CNN, but when it's now trying to inspect the network, then it gives me this error, says dot indexing is not supported for variable of this type.
Okay.
So I can print my screen if it helps.
Sure. Okay, what I'll do is I'll probably stop sharing. Can you share your screen shortly so that we can kind of see?
Okay. Just a minute. Can you see my screen now?
Not yet, I guess. Yeah, it's loading.
No, can you see it now?
Yeah, it's visible now. I think, yeah, so you are on that MATLAB drive window. Can you shift to MATLAB?
No, I'm showing this live screen. Give me a minute, I'll stop and I'll share again.
No, the live script is not visible. I think the MATLAB drive window is visible. Can you reshare if possible?
Let me just
sure.
Let me share again.
Sure.
Can you see my screen now?
Because it will load in a while. Yeah, I think it's running while loading an object of series network and validating the data, number of channels. Okay. Can you scroll up slightly?
Okay.
At the top. Can we take a look at the workspace where the network is kind of labeled?
Yeah. This is something I was running last night, so I could clear it.
So I just wanted to see whether the net object is kind of
Loaded.
Loaded, yeah.
Yes, loaded. See it, yeah.
The workspace is not visible, I guess. So if the net is loaded, I think it should run well. This is which version of?
So it's arrow 2022A.
Okay. Maybe something has to do with the version. I'm not really sure. If we can see the workspace, whether the net object has been loaded, it will be easier for us.
Can you see the workspace, or should I?
Workspace is not visible yet, I guess.
Really?
Yeah.
Let me undock it.
Yeah. So if you can share the entire screen, I think then instead of a single
Can you
window.
see? Okay.
Hello, Pratyush.
Yeah, sir. Yeah, please.
I think we can take these questions after completion of your session,
Yeah.
so that because
yes.
individually, if you are going for questions, that
Yeah,
will
I
be
think
the
it will.
problem.
Right,
Yeah?
right. Absolutely. We can do that. Right. So maybe not a major error. Maybe it has something to do with the version. I'm not entirely sure. But yeah. So great. So what we were going through here is we're taking this problem where we have some kind of data generated through multiple modulation schemes, and we were trying to predict what kind of modulation scheme it was. So if you want to build some kind of intelligent receiver which can predict the modulation scheme and accordingly, demodulate signal, so that can be a use case where these kind of network can be used. So what I'll do now is I will jump to the second folder, okay, where we will actually build the network and try to use it. So for that, just go to the second folder. It's called modulation classification. And just click on the solution _ modulation classification. Okay. So just like I mentioned earlier, this is the problem that we are trying to solve. We are trying to kind of understand how we can distinguish or discriminate between different modulation schemes by using a neural network. Okay. So again, the same drill. First, we will see whether we are in the correct directory or not. Then we have the entire data, okay, and all of that data is kind of captured in this mat file, okay. So the data that we will use for training our neural network, that has been stored in the mat file. So if we load it by clicking the load option, everything will be loaded here. So as you can see, regarding the data, here a description has been given. So we have data frames which are pretty much 1024 samples long, and for every frame, for every type of modulation, we have 200 frames, right? So I'm talking about how the data is kind of distributed across multiple modulation schemes. So there are 6 modulation schemes, right? And for every modulation scheme, there are 200 frames. So 200 by 6, there are 1200 frames in total. Okay. And so out of these 1200, what we will do is we will take 80% of it for training and 20% for it for testing. Okay. So there are, if you take 80% of 1200, that's 960. So 960 training frames and 240, that is 20%, that will be testing frames. Okay. To further deep dive into the kind of data that we have all the frames that we have, they are 1024 samples long, and they have this sample rate of 200 kilohertz. And typically 8 samples represent a symbol, right? In digital modulation. So you can kind of calculate how many symbols are there in this for each frame. Okay. So once we have the data, once we have the frames, if you notice here, these are 1024 samples long, and these are complex data, right? So if I point it here, it says 1 cross 1024 complex, which means it has the in-phase and the quadrature part, which is why it's complex data. Once we have that, what we can do is we can take the training frames and the training labels. Okay, so the label is essentially the name of the modulation scheme from where the data has been generated. So, and the frames are the data. So what we can do is we can take the spectrogram of them just to see what they look like. Okay. So if I run this, we have this function called hplot spectrogram, which is taking the training data and the training labels. Okay. And it is generating the spectrogram for them. It will take some time to generate the spectrogram for multiple modulation schemes. Okay, and once it is done, we'll get to see this. Okay. Now, this kind of explains why do we need a neural network to kind of distinguish between them. Because if we just look them with our naked eyes, they kind of look similar, right? We are not able to really distinguish. There might be very minute differences, but essentially at this zone you get to see yellow kind of bands, and the rest of it is pretty much orange and green, right? So visually it's very difficult for us to kind of distinguish between them, and it can come from any modulation schemes, which is why we let a deep neural network kind of identify more subtle patterns which are there in these kind of data. Now, you can design these network in multiple ways. Okay, one way to design that would be through something known as a deep network designer app. Okay, so how do you access a deep network designer app? So you just go to apps tab. And here you just click on this drop down. Under machine learning and deep learning, there are multiple apps. So apps are essentially tools where you just pass the data. You don't have to necessarily write codes. MATLAB will itself write code for you. But if I click on one of these apps under machine learning and deep learning, you will get to see the deep network designer app. Okay. So if you click on this, the corresponding app will open. Okay. Once this thing opens, I will show you how you can design your own neural network from scratch. Okay. So this is what the app window will look like once you click on the deep network designer window. Okay. So now it will kind of ask me to do multiple things. So in a deep network designer, you can either design things from scratch, which we will do now, or if you have already built a neural network in some other paradigm, you can export that to MATLAB also. For example, if you already have a neural network designed in some other, deep learning library, say PyTorch or TensorFlow, you can directly export those networks to MATLAB so that your work is not getting hampered. So if you are working on a project where maybe your colleague or you have already designed the neural network part, and if you want to integrate that to the communication systems algorithm part, which you have designed using MATLAB, so that is possible. Or you can design it from scratch also. Or you can also use these kind of pre-trained networks, which are downloadable from MATLAB itself. You can directly add them or install them. That is also possible. For our case, we will directly start with a blank network. Okay, and here you can kind of design things, right? So, for example, in our case, we can start with a sequence input layer. Okay, so click on this one because the data that we are using is a time domain signal, right? It's a waveform. So for those kind of data, you can bring a sequence input layer. Then you can bring a conv 1D layer and kind of connect these two. Okay. Then we can bring a ReLU layer and connect this one. Okay. If these two things are getting repeated multiple times, then we don't have to separately drag and drop them always. What we can do is we can Control C, copy them and paste them and kind of bring them here and connect them again and so on. You can keep on making it further deeper. Okay. So before that, before we kind of deep dive in, go ahead with training and all of that. How many of us are really aware of what these layers do? Are we aware of what a conv 1D layer does or what a ReLU layer does? Yes or no in the chat again? Why are we using them? Yes, no? So we are essentially building a convolutional neural network, right? And convolutional layer or ReLU layer, these are typically part of the network architecture. But have we heard of these layers, conv 1D or ReLU, or do we know what kind of action they perform? Yes, no? If you are not aware, I'll further explain. If you are aware, maybe I'll skip that. But are we aware? I think someone mentioned you know how a ReLU works. Okay, that's good to hear. Others? Someone mentioned no. Are others aware what they typically do, or why are we stacking them in this way and not any other way? Yeah. Okay. Great. I'll explain in that case. So, whenever we are talking about convolutional neural networks, right? So there are layers called conv 1D in this case because the sequence data is a 1D data. If you have an image which is 2D data, we would have used a conv 2D kind of a layer. But the idea is these are essentially filters which operate on your data to extract features from your data. Okay. So, and the way they extract features is through a convolution operation. So it's like one layer, and there will be multiple filters to this particular layer, which you can decide here. So if you want 32 filters, 32 different filters will work on this data, and they will extract 32 different kinds of features. Okay. And individual filter size will be this one, 3. Okay. So a filter of size 3 will operate through the entire waveform to extract features, and there will be 32 such filters. So 32 different types of features will be extracted. Okay. Then once you are done with this one, then comes something known as a ReLU layer, which is like some kind of non-linearity. So the relationship in real life between input and output is always a non-linear one, right? It's never a linear relationship. So if you are only using the convolutional layer, these are always linear operations, and you will not be able to capture non-linear relationships between your sequence input and your class output, which is why to introduce these nonlinearities so that your network is able to identify a lot of nonlinear patterns within the data. Okay, so that's the overall idea. I mean, I'm not getting into the mathematical side of it, but the idea is to establish a nonlinear relationship between input and output, and your conv layer and your ReLU layer helps you to do that. Okay. Now, once that is done, you can add other layers also. For example, there is something known as max pooling. So if you look at global max pooling 1D, it will just reduce your data to some extent so that you can save some memory. And finally, once that is done, you can connect a fully connected layer. Now, if you remember the problem, in the problem, you have to predict classification, right? So what kind of modulation schemes were there? There were 6 modulation schemes, which is why this fully connected layer output will be 6. It totally depends on the different types of output that you have. Okay. In this case, that is 6, which is why we are connecting a fully connected layer of output size 6. Finally, you will have a softmax layer, which will convert your data to probabilities. And the highest probability corresponds to a certain class, which we will be able to predict. And this is a classification problem, right? So we need a classification layer at the end. Okay. So this is how you kind of connect all these layers. Once you have designed it, you can actually export this thing to workspace and further continue with this. So a good part about using the deep network designer is you can connect different layers and kind of visualize them and change their properties on the go. Okay, so it's very easy to visualize things and export things. If you are not comfortable with that, you can continue with the usual approach, which is writing codes. Okay, so you can do the same thing using codes also, and you can define the properties here. So this is how I kind of design my network. Okay. Once I have designed the neural network, I can set training options. So I have the data with me. I have designed the neural network which will predict my modulation type. And I have certain training options, which means how do I want to train my network? How fast do I want to learn? What is the learning rate? Okay. Or what is the number of iterations for which I want to kind of train my network? So these are some things which we can also set, okay, by using this training options command. Okay. So if I run this, everything will be set. Okay. So just to summarize, first we took the data. The data came from 6 modulation schemes. We divided the data into 80:20 ratio. 80 will be used for training, 20 for predictions. Then we designed the network. The network layers were essentially these. Then we had different training options. What will be the learning rate? What will be the number of epochs, and so on. Finally, once we are done with all of this, we can pass the training data, the training labels, the network that we designed, and these options, training options, and use this train network command. Okay. If I run this, the training of the network will start. What does training of a network mean? It essentially means that you are showing this network the input and the output, and it is able to predict the patterns within the data. Okay, so how does a kid learn to identify objects? You just show the kid multiple images of the objects, right? Once it is able to see enough data, it is able to learn. Like, okay, this is my father, or this is my mother, or this is a cat. So that is the exact, that is what, or that is how a neural network also learns. And we can also see the progress of the training here. Okay. It will take some time to kind of run through the entire thing. Okay, so the training is showing that, the training iteration is going on. And you will get to see the accuracy and everything. Okay, so the training starts. And you can see the training progress has also loaded. So depending on the hardware that you have, your training might speed up or slow down. For example, currently I only have access to a CPU, which is why my training might take some time. But the idea is, if you have if you have GPUs, which are like very dedicated hardwares for processing large amount of matrix data, your training will surely speed up. For example, here I can see the accuracy kind of increasing, right? It increased at least from 20% to around, I don't know, 45 or 50% now. And it will take some time to increase it to a significant value. And at the same time, you will see the loss value also decreasing, right? So this is something which we are optimizing certain things. We are optimizing the parameters of our network by reducing this loss value. As the loss value will decrease, we can expect the accuracy to increase. Okay, so that is the idea. The accuracy is currently around 60%. It's kind of increasing. And we have barely trained, we can run it for 1050 iterations, right? But currently it's just 40. As it kind of increases, we will definitely see the accuracy going up. Right. So let's give it some time. Once it kind of goes at least close to 80%, we will stop the training. Okay. I think it has surpassed 60% now. And in parallel, you can kind of see the values also. So at iteration 1, the mini-batch accuracy was 14%. Now it's 57%. Now it has surpassed 60. In the next update, you will probably see it crossing 70 or something. So, but this is typically how a neural network trains. Okay, as it sees more and more data, it's definitely able to identify patterns, and it's able to do well on unseen data. Okay, which is why the accuracy goes up. So now we kind of see the accuracy going up to some extent. So it's kind of close to, I don't know, 75% now. And it's still oscillating in that zone. Okay. Once it crosses the 80%, I think we will kind of stop. close. Okay. Yeah, I think as far as the value is concerned, we are pretty close to 80%. So I'll stop the training now because it will take some time to really stop the overall training procedure. So if you notice here, it's saying, training has finished. It has been stopped manually. That we can do. So whenever you are training something, if you are happy with the accuracy value and you have less time, you can stop it manually. Once it stops manually, you can continue with predictions, right? So I'll close this. The overall image is also captured here. So if you want to attach and show the training process as part of your research project or something in your research paper, you kind of want to show how your accuracy improved over time, you can attach these kind of images to that. Okay. So we have the network now. It's giving around 80.47% mini-batch accuracy. Let's say we are satisfied with that. Now what we will do is, we will take the test frames, okay, and take the prediction network, okay, and we will use it to classify the data, okay. So we have the actual test labels, and we are using the test frames to get the predictions, okay. Once we do it, we want to see how much accuracy is there for unseen data. So if we do that, we can see a test accuracy of 77.91%, which is 78%, which is, I guess it's okay. If we had trained it for a longer period of time, that would have reached 90% or something, and we would have achieved more kind of the accuracy values would have gone up for sure. So an interesting thing here is the confusion matrix. How many of us have either heard of or used confusion matrix in the past? If you have, again, yes. If you haven't, can you type no? Or what it kind of implies, confusion matrix, or why is it really important for using AI, especially deep learning? You haven't heard of it. Okay, that's great. We will talk about that. But others heard of confusion matrix. So this is what a confusion matrix essentially means. It identifies how your machine learning model or how your CNN or deep network that we have used here, how often it gets confused while doing predictions. Okay. For example, horizontally, you have the predicted class, right? Vertically, you have the true class. Now, a particular matrix instance corresponds to a certain true class and a certain predicted class. For example, if I take this one, this is the intersection of this horizontal line, which is 64QM true class and GFSK predicted class. So this number true class, okay, which means for these many number of instances, our model is getting confused and making wrong predictions, right? Because for this one, the true class is 64QM and the predicted class is also, the true class is 16QM. The predicted class is also 16QM. So these are correct predictions because the true class and the predicted class are same. Whereas for this one, the true class is 16QM but the predicted class is 64, which means for 5 instances, my machine learning algorithm is making wrong predictions. And for 2 other instances, it is again making wrong predictions. Okay. So that is a common thing, because in a lot of the cases, especially if the modulation schemes are kind of same, it can get confused, right? For example, here for 64 QAM, it is making 13 correct predictions, but 25 incorrect predictions, because both of them are QAMs. Okay, it is easy to get confused between same kind of modulation schemes, albeit the order is different. Similarly, for QPSK or even within different PSKs, there is this confusion, right? So how do we improve that? How do we make better predictions? There are multiple ways. For example, you can change the architecture of the network. You can make it deeper. You can introduce more layers. You can change maybe some of these training options. Okay, maybe change the learning rate. Okay, maybe change the max epochs. These can be one. And maybe change the architecture here. I mean, you can change these values. You can increase number of layers or decrease number of layers. You can experiment with all of that and see whether this value changes. Here we stopped the training at only 78% accuracy. If we had trained it for a longer period of time, it would have given us better predictions. But overall, this is the idea when it comes to using deep learning for a particular case. So to summarize, the problem at hand was to classify different modulation schemes, because we want to design an intelligent kind of receiver which understands the modulation schemes and applies demodulation algorithms accordingly. And for that, we used a deep neural network. We took different frames of data from 6 modulation schemes. We divided it into 2 parts, one for training, one for testing. We trained the network once we had the data, and then we tried to do predictions and then tried to understand how our network did when it came to unseen data. It did okay, but we stopped the training at a certain percentage of accuracy. If we had trained it for longer period of time, this value would have increased, and we would have, it would have met lesser number of errors. Okay, and this value would have definitely gone up for test accuracy. Okay, so I'll stop here. I think we are probably towards the end of the first part of the session. There's a question on video lectures on MATLAB and AI. Definitely. Please hang around for the second part. Once I have completed the entire session, I will point you to resources which can further help you to kind of understand better. But it's a good question. There are video lectures for sure. Towards the end, I will just give you maybe a plan which you can follow to use AI better with MATLAB and for multiple applications. Any other questions? You can put it on the chat or maybe unmute yourself and say. Any questions? Was this overall demo okay? Like in terms of, was it a bit too advanced or was it understandable? Like yes or no, just for me to understand. Like what we are